Okay? Now, as we said in confidence intervals, we're not 100% sure in statistics. I can't say that I accept the null, that I am 100% positive that the mean is equal to something. Just like we saw in confidence intervals, we were 95% confident that the answer was in a certain range. Okay? Now, so if that's the case, then sometimes we're going to come to the incorrect conclusion, even though we did everything correctly. So sometimes we do all of our stats perfect. We do everything exactly the way we're supposed to, and we still come to the wrong conclusion. Okay, so we're going to talk about those types of errors, so to speak. We will make errors even though we did everything exactly right. It's not a error in the sense of a mistake was made. It's an error that is inherently built into the inference process, that sometimes we're going to come to the wrong conclusion even though we did everything right. Okay, so what are these type 1 and type 2 errors? Okay, so a type 1 error is when we reject the null when in fact it is true. We reject the null when in fact it is true. Well, what's the probability that we reject the null when the null really is true? Well, that's going to be the alpha level. So there's a if the alpha level is 0.05, that means there's a 5% chance that we're going to reject the null when really the null is true. So a type 1 error is when we reject the null when in fact the null is true. Okay. What is a type 2? Well, it's the opposite of that. We fail to reject the null when it is false. Okay. There's this cool little table right here, okay, that shows us type 1 and type 2 error. Okay. The row variable is the conclusion based off of the sample. Okay. The column variable is the truth. Okay. So we reject the null when in fact it is true. That's committing a type 1 error. The probability that we commit that error will be equal to the alpha level, which is usually 5% unless otherwise stated. Well, a type 2 error, we fail to reject the null when the alternative is true or when the null is false. So if the truth is that the null is true and we fail to reject it, then we've made the correct conclusion. If the truth is the null is true and we reject it, well, we were wrong. That's a type 1 error. If the truth is that the null is false or the alternative is true and we reject the null, then we've done the correct thing. If the alternative is true or the null is false and we fail to reject the null, then we've committed a type 2 error. So again, type 1, we reject the null when in fact it is true. Type 2, we fail to reject the null when it is false. We're going to be asked to identify a type 1 and type 2 error in context of the problem. And then we're going to probably be asked to talk about which error would be more important, which error would be more detrimental, what would the consequences of committing these errors be. Whichever one has a more extreme consequence, we want to try to avoid making that error the best of our ability. And we know how to change the probability of making a type 1 error by fixing the alpha level. As we move through this, we'll look at how we can minimize the probability of committing a type 2 error. All right, so I'm going to erase this and let's take a look at an example so we can put this in context for type 1 and type 2 errors. So a potato chip producer and its main supplier agree that each shipment of potatoes must meet a certain quality. If the producer determines that more than 8% of their potatoes in the shipment have blemishes, the truck will be sent away to get another load. Otherwise, the entire truckload will be used to make chips. To make this decision, a supervisor will inspect a random sample of 500 potatoes from the shipment. The producer will then perform a test at the alpha equals 0.05 level. So you can see that they've written this out for us. Okay. And now the examples we've used previously have all been quantitative data. So the null was in terms of mu. Well, this is what proportion of the potatoes have blemishes, or categorical data. Okay? Does your potato have a blemish? You don't say 6, right? You say yes or no. So this is not quantitative, it's categorical. Therefore, when we define the parameter, we're not defining mu anymore. We're defining P. In this case, what is P? Okay. P is the true proportion. The true proportion of what? The true proportion of potatoes. What about the potatoes with blemishes? What potatoes are we talking about? The potatoes in this truckload. So we need to be very specific when defining the parameter. We need to give the problem context. So P is the true proportion of potatoes with blemishes in this truckload. Now, we're not going to check every single potato. As you can see in the example, the supervisor inspected an SRS, or a simple random sample, of 500 potatoes from this truckload. Okay. So we did not look at every single potato. Again, what is inference trying to do? Take a small sample and answer a question about the entire population. And in this problem, we're supposed to describe a type 1 and a type 2 error in this setting, and then give the consequence of each. Okay, so in context of this problem, what is a type 1? So what did we say about type 1 error? It's a type 1 error occurs when we reject the null when in fact it is true. So in this case, we say at type 1, the potatoes, oops, I don't like the way I started that. Let's say a type 1 error is we reject the null. So we're saying that there is more than 8%. Okay, so a type 1 error, we find convincing evidence that more than 8% of our potatoes have blemishes. When in fact they don't. What's the consequence of that? If we came to that conclusion incorrectly, what is the consequence of making that type of error? Again, this is not an error that we made in calculation or we made a mistake. It's just inherently built into the process of running a significance test. In inference, this is going to happen at times. We're going to come to the wrong conclusion, even though we did all the work correctly. What's the consequences of this? We send the truckload back when the potatoes were actually good enough. So we wasted time, We upset our provider of potatoes. We wasted money when really we didn't need to. So we send the truckload back when the potatoes were actually good. That is a consequence of committing a type 1 error in context of this problem. What's the probability that we do this? Well, it's the alpha level. The probability that we committed that error is 5%, 0.05. That's the probability that we shipped back a good truckload of potatoes. Wasted time, wasted money. Okay. I don't have enough room here, so let me clear this off and let's look at a type 2 error in context of this problem. Remember, type 2, we fail to reject when in fact it's false. Okay, so a type 2 error, we say the potatoes are good, meaning the potatoes have less than 8% blemishes, when in fact they had more than 8%. What is the consequence of committing this error? We say, yeah, this batch of potatoes is good, when in fact they're bad. So the consequence of this is we made a whole bunch of chips with too many blemishes. We made a whole bunch of bad chips. We package them up, we send them out, we send them off to the store, and now our customers don't like our chips anymore and they quit buying it. Our business goes bankrupt and we're all on the street begging for quarters trying to survive. Okay. So type 2 error in this case is much more serious than a type 1. Type 1, we sent away some good potatoes. A type 2, we used bad potatoes and therefore could have cost our business. We could have lost customers. Okay. So the consequence of a type 2 error is using bad potatoes to make our chips, which is going to upset our customers, costing us lots of money and possibly our entire business. So a type 2 error would be what's the right word? Type 2 error would be more serious in this situation. I don't know why it was hard for me to find the word serious there. All right, so type 1, type 2. Type 1, we reject the null when in fact it is true. Type 2, we fail to reject the null when in fact it is false. And here's an example of each kind.